Okay, so today we're going to look at factoring trinomials that are not perfect. They're not square rootable on the ends, and the double of the middle is not there. And why are we doing this? Well, when you multiply parentheses together, you don't know what they had before they multiplied it. And then looking at this right under the objective 1 in factoring trinomials, if I multiply x plus 3 times x plus 5, I don't know these middle terms were 5 and 3 added up to 8 once they add them. I don't know if it's 1 and 7 or 2 and 6. I have no idea what that was that they added together to get that 8. But I need to know that in order to be able to factor it. Because if I could figure that out, I could split the problem right here and factor it and get back to the original problem. So our goal today is to take this linear term in the middle and figure out what did they add together so that we can split the problem and do grouping. Now first we're going to focus on some problems that are kind of short so we can focus on the signs. And as we focus on these signs, I may not do both questions every time because to save a little bit of time since I'm recording this and I'm not doing it during class time. Alright, so to begin with, when the problem is all positive, you know that your problem is going to have all positives in the answer. So that's why I only need really one of these. But the process is you multiply the first number times the last number. And you make a list of factors of 12. Because 1 times 12 is 12. But it's not the only factor. 2 and 6 make 12. 3 and 4 make 12. But then you want to know which pair added to make this 7x. And as you can see, 4 and 3 add up to 7x. So we're going to change the problem now to have 2 linear terms in the middle because now we know what the person added together when they FOIL this out. We know what they added together to get the middle. Then we can split the problem. The split the problem grouping is the 5th step. The first step was to multiply 1 times 12. The second step was to list the factors. The third step was to figure out what signs we need, which is all positive. The fourth step is to figure out which ones add up to the middle so you can insert them in your problem. And that 5th step is grouping. So we do the same thing we did yesterday. We take out the GC in each half of the question, and then we take out the GCF of the whole problem, which is x plus 3, and that leaves us with x minus 4. Now, the second problem works the same way, so if you want to stop the video and work the second question and see if you can get it, you can, but I'm going to move on. And I have this handout for y'all, so if you want to do this video and take yourself some notes, you could wait and do it when you get the video, the handout. Yes. All right. So you're stopping the video now. Well, I started putting x's in the problem, so I'm going to just use x for a minute. Sometimes when you're working these questions, if you change your variable, it makes it a little easier. One of the students asked me about that today, so I thought I'd show that. If it bothers you that there's different variables all the time, then you can change them back to v's at the end. But since I already wrote it with x's, I'm just going to continue with x's and put my v's back at the end. So my answer is v plus 1 and v plus 20 because there's only one way to make 20 add up to 21. Now in our second example, we're going to look at what if the middle is negative but the last one is positive. Again, you're going to multiply the first number times the last number, which is 42. That makes 1 and 42, 2 and 21, 3 and 14, 6 and 7. But if I add these, they're all going to make positive numbers. Although this one makes positive 17. It doesn't make negative 17. But two negatives multiplies to be a positive. So if I put negatives on all these numbers, then two negatives multiply to be a positive, but add up to negative 17. So now we're looking at d squared plus, minus 3d minus 14d plus 42. So we found the two numbers that somebody added together that make 42, but add up to 17. Now we split the problem. Take out a negative 14. That'll make d minus 3. So my factorization is d minus 3 and d minus 14. Now, it wouldn't be wrong if somebody said d minus 14 and d minus 3. It doesn't matter which parentheses first, as long as the stuff in the parentheses is the same. So if you want to stop the video, you could work the second question and see if you can get it with the negative positive pattern. Again, your factors all have to be negative because that's the only way to multiply to be a positive. It adds up to negative 11 if you use negative 2 and negative 9. So x squared minus 2x minus 9x plus 18. Split the problem, take out an x. X minus 2 will be left. Take out a negative 9. X minus 2 will be left. So it's x minus 2 and x minus 9. Now, in both of these examples, it has ended with a positive. And that made my list have both the same sign. In our next examples, we have two where they end in negatives. But you'll notice the middle are not the same signs in both these questions. We have to look at it from the perspective of what if the end is negative, but the middle is positive, or what if the end is negative and the middle is negative, because that is two different thoughts. So 1 times negative 27 is negative 27. That makes 1 and 27, and 3 and 9 are possibilities. But for it to multiply be a negative, one of those two numbers has to be negative. But it's got to add up to 6. So that means you've got to add a larger number that's positive to a negative, smaller number. Because that's the only way it's going to come out positive. Because it's got to be one of each to multiply to be negative 27. So therefore the negatives need to go on the smaller number in this case. And it does make a difference sometimes where you put that negative. I like my negative to, if I only have one of them, to be in the second hole, because that saves you a little bit on the split the problem if you don't put it in the third hole. So m out would make it m minus 3. 9 would make it m minus 27. Minus 3, out of the 27. So that makes it m minus 3 and m plus 9. Now you'll notice in all these problems it looks like I'm just filling these parentheses in with the numbers off the list. Don't think that, because that can be a misnomer. And this particular problem set, that might be true because I'm starting with a 1. But not all polynomials start with a 1. So therefore that's a little bit of a misnomer that students make. So 1 times negative 18 is negative 18. That means I have 1 and 18, 2 and 9, 3 and 6. But I want it to add up to this negative 3. So that means to a positive and a negative are only going to add up to that if the negative one is bigger. So therefore, that makes my pattern the last one. And this is what I was talking about before. I have a choice on whether I want the 3 or the negative 6 to be the second hole. And I would put the negative 6 because I don't like my negatives to be in the third hole because I don't like taking out negatives. So I take out a p minus 6. Take out a 3, p minus 6. So p minus 6 is one of my parentheses, and p plus 3 is my other. So we've just practiced really with this what the signs need to be so that we didn't have to struggle with the numbers as much because there wasn't a number at the beginning of these questions. Now this page is the 5 steps that we've just been doing. And again, let's go through those. So step 1 is to multiply the coefficient on the x square, which is called a, times the constant c. Then you take that number and you make a list of factors of all what that product would be. And then you have to choose in step 3 what signs you need based on does it end in a positive or a negative, because that makes a difference on whether they're alike or different. Then you take the 2 linear terms that you come up with that adds to the middle and replace the linear term in your problem with the 2 linear terms. Then you split the problem, and step 5 is do all the grouping. So let's try some that have a number at the front. Here we're going to work on problems that end in a positive c, and we have one example of a positive on the end and a positive, and one with a positive and a negative in the middle. So 6 times 7 is 42. So you always multiply your first number times your last number. 42 has factors, 1 and 42, 2 and 21, 3 and 14, and 6 and 7. I'm looking for one that makes 23. And because my problem is all positives, it's got to add up to positive 23 with 2 positive numbers. So then I take out the linear term. Whoop, I'm putting x's again. Take out the linear term and put in the 2 linear terms to replace it, because these 2 linear terms make that. Split the problem. I can take out a 2n. That leaves me with 3n plus 1. I can take out a 7, which leaves me with 3n plus 1. So therefore 3n plus 1 is one of my parentheses, and the other one's 2n plus 7. Now, if you'd like to stop the video and see if you can figure out the second one, you can, or you can just continue taking notes. So if you do 2 times 2 is 4. That's 1 and 4, or 2 and 2. But all positive numbers is not going to make negative 5. But then again, 2 negatives multiply to be a positive. So negative 4 and negative 1. Now again, it doesn't matter which place the negative is in because they're both negative. So we'll put put them in the same order they're listed, unless you only have one negative. Then you really should think about it. So I split the problem, take out a y, that gives me 2y minus 1. Take out a negative 2, that leaves me with 2y minus 1. So 2 minus y is one of my parentheses, and y minus 2 is my other one. So then, what if it ends in a negative? Well, here we have an example of both of that. And as you can see, 7 times negative 8 is negative 56. Well, that's kind of a big number. So let's talk about what if we couldn't find all the numbers we needed because we're not listing them correctly, or it's taking too long. Well, one way you could do that is you could go to y equals, type in the number that you need, divided by x, and your table will make you a set of factors. And I need to go up and see what 1 times 56, that's not 26. 2 times 28, that'll add up to negative 26, which I think is what we were doing. So we found it out right away. So we needed negative on the 28 and a positive 2 that multiplies to be negative 56, but adds up to negative 26. So this time I do want my negative 28 to be first and my positive 2 to be second, because I don't like my negative in the third hole. Now you can do that if you want to, but I don't like working with negatives. So I always put my negative in the second hole. So 7x means x minus 4 will be left. Positive 2 out means x minus 4 will be left. So 7x plus 2 and x minus 4. All right, let's look at this last example of what if a negative is in the end. 2 times negative 3 is negative 6. 1 and 6, 2 and 3 are the only ways to get 6. But since it's negative on the end, I got to have one of each to add up to a positive, so the smaller needs the negative and the positive's got to be the bigger one. So 2n squared minus 2n, because this adds up to 1, plus 3n. I kept it in the same order because the negative one was first. Split the problem, take out a 2n, that gives you n minus 1. Take out a 3, gives you m minus 1. So then you get m minus 1 times 2m plus 3. Now this might be a good place for you to stop and go do your word assignment. In Canvas there is a worksheet on this, and the first set has all positive on the end. The second set has all negative on the end. So it might be a good time for you to stop and do that before I give you the rest of the notes, because the rest of the notes have more steps. They're a little bit more involved. So I would stop the video and do part of that assignment. But once you start the video back up, you'll notice that these 4 questions could all have something taken out. And you have to take out the GCF on every question before you ever do any other method. For example, if I wanted to take a 2 out of this one, that would give me v squared minus 6v plus 5. Now 1 times 5 is 5, but there's only one way to get 5. But they both have to be negative to make negative 6. This is a problem in which you could shortcut it because there's no number in front of v squared, and you could just go straight from the table to plugging it in your parentheses. That does work, but it does not work if it doesn't start with a 1. In this problem, I could take out a 5. That leaves me with 4x squared plus 16x plus 7. 7 times 4 is 28. 1 and 28 are all positives, so this should be all positives. That doesn't make it. 2 and 14 does. So 4x squared plus 2x plus 14x plus 7. Split the problem. We have 2x, 2x plus 1. Take out a 7, 2x plus 1. You see that grouping works the same as it did yesterday. 2x plus 1 is one of the problems, and 2x plus 7 is the other one. But when you finish, you got to remember to bring this GCF down because it's on the whole entire question. And the same thing works over here. I can take out a 6 here. And that'll give me a 3k squared minus 2k minus 1. Now, when I was in school, I was taught to guess and check. And guess and check is not the best method. Although on this question, you might could guess and check. I just thought I'd show a one that guess and checking just to give you an idea of how that works. So 2 things that multiply to be 3k squared would be 3k and k. And 2 things that multiply to be 1 negatively is a 1 and a 1, but I got to figure out where to put that negative and positive that make negative 1. And I think this is the right possibility. Let's see. If I did the outer and the inner, that'd be negative 3k and negative 2, 1, and positive 1 makes negative 2. I'm good at this because I've been doing it for many, many years, but it's not the best method. Because sometimes you might have lots of possibilities, like this one over here with this 28. If I just started trying to fill out all the factors, I don't know if it'd be 2 and 2. It could have been 1 and 4. I don't know which one of the places it would go in. So guess and check is not the best method, although once in a while you look up and it works. That's why I like this grouping method. It works every time. So I can take a 2 out of this problem. 3 times 4 is going to make negative 12. So there's 1 and 12, 2 and 6, 3 and 4. For it to add up to a positive 11, and with one of them being negative, that means the little one has to be negative, and that makes it the first one. So then I have 4y squared minus 1y plus 12y minus 3. And I split the problem. I take out a y, 4y minus 1. I take out a 3, 4y minus 1. And then I say 4y minus 1 and y plus 3 are my grouping. But don't forget to bring down your 2 you took out, because if you lose your greatest common factor, it's incorrect. And you will not get full credit. So in Canvas, we have under modules, oh wait a minute, I'm not even in the right class, hold on. Alright, so in Canvas, under this lesson, worksheet 2.5, let me bring it up. You'll notice the first ones are all either all positive or positive on the end. The second ones all have a negative on the end. And the third set is what I just showed you. Some of these have a GCF that needs to come out before you start doing grouping and figuring out the 5-step method on it. So, go ahead and try this assignment and see if it works. And I know the section number up here is incorrect. The section number is supposed to be 2.5 because I'm renumbering a unit. I keep forgetting to renumber different pieces of it. So it's 2.5 homework that you're doing for a worksheet grade. And we got a lot of it done in class today, so I hope you at home will be able to. So I'm now going to stop the video so that you can do your assignment.